Hello everyone. Today we are going to start with the chemistry chapter number 1, that is solid state. In this chapter we are going to discuss in details the properties of solids. You might have gone through about the properties of solids in lower sections, that solids have a fixed shape, they have a definite volume, right? The intermolecular forces are very large, intermolecular space is very small, and all such things, but somewhat in details, that what exactly the solids are, what different types of solids are, what exactly type of the bonding is present in the solids, how do we classify those solids, the solids which we see surrounding us, what exactly those solids fall into the category of. So all such things we will be seeing in the today's lecture. So to begin with the introduction, right? Solids, it is the one of the state of matter. You must be knowing that there are four states of matter: solid, liquid, gas, and the fourth one is plasma. I do not have exact idea whether the plasma is recognized as a fourth state of matter or what, but three states are confirmed, that is solid, liquid, and gas. So out of those three states, we are going to see solids in the much detail. Right, regarding solids, you must be knowing that the intermolecular force is very large. Intermolecular force, it is a force between the molecules, right? And in case of the solids, the intermolecular force of attraction is very large. In case of the liquid, it is small. And in case of the gases, the intermolecular force of attraction is least. Then the intermolecular distance, in case of the solids, it is very large. Sorry, in case of the solids, the intermolecular distance is very small. In case of the liquids, it is quite large. And in case of the gases, the intermolecular distance is very, very large. Cohesive force, it is a force between the same type of particles or same type of molecules, right? Cohesive force, when you say that the water placed in a beaker or in a container, the molecules of the water, they are bound to one another by some type of force. The forces, there are multiple, there are different types of forces, many names exist for them, but overall a general word which exists, a general word for the force between the same type of molecules, that is the force between the two water molecules or multiple water molecules, it's called as cohesive force. Co means cooperation, cooperative, right? And cooperation happens between the same type of molecules. So that is how you can remember that cohesive force, it is a force between the same type of molecules or same type of particles. Adhesive force, it is a force between different type of molecules or different type of particles. You might have seen the Fevicol, right? If you closely see the Fevicol box on it, it is written that it is a adhesive. What do we mean by adhesive? Adhesive means it joins the two different type of particles or two different surfaces. We use fevicols to join the two wooden plates, right? We use the fevicol to paste the paper on the wall. So it is a adhesive, right? A different type adhesive, it is a force between the different type of the molecules. Van der Waals force, I told you here that between the molecules there are so many different type of the forces, depending upon how they have come into existence, depending upon nature of the discoveries, those force of attractions are given different names. So one of such type of the force, and for sure Van der Waals force, it is the attractive force, and mostly it is a very weak force discovered by the scientist named Van der Waal. Mostly this word is used with reference to the force of attraction between the gaseous molecules, right? Gas molecules, we know they are very far apart, and the force of attraction is very weak. So that weak force, right? Such weak force, we call it as a Van der Waals force. It is a weak force between the participating molecules or the same type of molecules. Electrostatic force, it is once again an attractive force, and electrostatic force, it is present between the charges. A positive charge and the negative charge, they both attract each other with a electrostatic force. A positive charge and a positive charge, they both repel with the electrostatic force. A negative and negative also repel each other with a electrostatic force. So that is the introduction to the solids. These are some of the terminologies which we will be using commonly in our discussion, right? Let us move on to the next topic. The next topic we have is characteristics of the solids. So most of them you must be knowing, you should be knowing how to reason them out. For simple understanding, I'll explain them. Intermolecular distance. So in case of the solids, the intermolecular distance it is small, right? The molecules are very close to one another, and that is the reason why solids have a definite shape. Intermolecular force, it is very large. The force of attraction between the molecules is very large. That force of attraction may be electrostatic type, or it may be cohesive type, it may be adhesive type, but whatever force it may be, in case of solids, the intermolecular force is very large, and that is the reason why they exist in the solid state. That is, they have a fixed or a definite shape. Then the Brownian motion is almost absent. Brownian motion means the random movement of the molecules. In gases, it exists. In liquids, it is there, right? If you drop a ink into the water, you will see that the ink gets slowly mixed up with the water. Such type of the motion of the molecules, right? We call it as a Brownian motion. So Brownian motion in case of the solids, it is absent. Solids are quite rigid, right? Their shape remains fixed. Shape does not get distorted. Even if you apply a force, the shape of the solids it remains unchanged. I'm not talking about the force applied by the machines. I'm just talking about the mechanical force which human may produce, right? Let's say this wooden board, I can produce some force. So if I apply the force, the shape of this board does not get changed. That is called its rigidity. Density of the solids is it's also quite higher, right? Since the intermolecular distance is small and the force of attraction is large, they are very closely packed, and so their density is large. Compressibility is negligible. Solids are not compressible, you may say. Even if you apply a force through machines, they may be compressed to the certain extent. But as I said, with the mechanical force, with the force that humans can produce, with such type of the force, solids can't be compressed. Then the diffusion is a property of mixing up, right? The particles of the solids do not get mixed up. Let's say you have a solid and one part of the solid you have colored it red and other part of the solid you have colored it green, right? If you keep it as it is, will you find that the colors get mixed up after some days? No, not at all. But in case of the gases, in case of the liquids, right, instantly we see the mixing up. So that mixing up, we call it as a diffusion. In case of the solids, diffusion is absent, or you may also say that solids does not show any property of diffusion. Melting point for the solids is higher. The reason for high melting point is that intermolecular force is large, intermolecular distance is small, right? Boiling point is also quite higher. Again, the reason is same, that the intermolecular distance being small and the intermolecular force of attraction being large. क्या दिमाग कट हो रहा है यार? Hello. Next one we have is diffusion. Diffusion is the mixing up of molecules within one another, right? If you drop a ink into the container having water, right, you will see that within no time, within few seconds, the ink get mixed up. The complete water becomes blue, black, or red, whichever color the ink you might have used. But in case of the solid, such type of mixing is not possible. Let's say you take a wooden plank, you color half of the part red and half of the part green. If you keep it as it is, even for the days, you will not see that the green color get mixed up with the red color or red color getting mixed up with the green color. So diffusion is almost absent in case of the solids. In melting point is quite higher for the solids, right, having large intermolecular force. to separate them, to convert their state from solid to liquid, large amount of the energy is required. So melting point is quite higher, and same way, since the intermolecular force of attraction is large, to make molecules completely free out of the bond or out of the force of attraction between one another, the boiling point, large amount of energy is required, and hence the boiling point of the solids is also large. So that are the common characteristics of the solid. Next, we move on to the different type of the solids, right? And into the different type of the solids. The main part of the chapter is crystalline solids and amorphous solids. The discussion on them. I have written that discussion in the form of differentiate between, so it becomes easier for you to understand. So let us see what are crystalline solids, what are amorphous solids, and we'll go through a comparative study of them. So crystalline solids are those solids, right, in which the constituent units, they are arranged in a well-defined pattern. What do you mean by a well-defined pattern? A well-defined pattern means you might have seen the construction of a wall, right? Bricks are placed in a well-defined order, and so the wall comes up. You might have seen the arrangement of the soldiers, right? Soldiers also, they are very well placed, one arm distance on the front side as well as on the left and right side as well as on the back side. So that is once again a very well defined arrangement, right? So such type of definite arrangement in a three dimension, right? Such type of the definite arrangement, if you find in the case of the solids, then those solids falls into the category of crystalline solids. So crystalline solids are those in which constituent particles are very well arranged in a definite pattern in all the three dimensions. The examples which I gave of a wall, it's only of a two dimension. Soldiers being arranged is of a it's again a two-dimensional arrangement, but if you have a Lego, right, you may try to arrange them in a fixed spot pattern in a three-dimension. Examples of a crystalline solids are NaCl. NaCl is just a table salt. If you have a crystal or if you have a solid table salt, right, you can analyze that table salt or a crystal or a piece of whole salt for all these properties. For sure, you will be able to see most of the properties in it. Another example of a crystalline solid, it's a diamond. Diamond is very costly, may not be available commonly with us to analyze all of these properties. But yes, sodium chloride, a common table salt, for sure it is available and we can analyze most of the properties in it. Let's go to the amorphous solids. Amorphous solids are those in which regular three-dimensional arrangement of constituent particles is missing. In other words, the constituent particles, they are arranged randomly. You may take example of a classroom, right? In a classroom, when teacher is present, the students are well arranged, one behind the other, right? One beside the other. They sit in a attention format. All of their faces are towards the board. A well arranged pattern you see, like crystalline solids. But during a recess time or when the teacher is not present, you may see that the students are randomly arranged. Some may be sitting on the bench, some may be standing, some may be their faces turned backside. So such type of irregular pattern is found in case of the amorphous solids. So amorphous solids are those solids in which constituent units are not arranged in a three-dimensional pattern, randomly oriented. Example is a PVC, rubber, right? The eraser which you have is a best available amorphous solid with which you may analyze most of its properties. Silica, you may take it as a clay, pot clay, right? The playing clay you might be having. So that is another example of the amorphous solid. So let us see few more properties of the crystalline and amorphous solids, compare them and understand them. Most important point under the crystalline solids is a short long range order and a short range order. What do we mean by this? As I said, that the constituents are arranged in a 3D pattern, right? So due to that pattern, there they have a long range order. Long range order means if you analyze the crystal at one corner, let's say at one corner, if you start the torch or if you start the lighter, let's say one corner starts burning or catches the fire in 2 seconds, the other corner will also catch the fire in 2 seconds, or any other edge will also catch the fire in 2 seconds. So that is what it means, like long range order. The same property you will find at different corners. They are short range order. Short range order means the arrangement pattern is only for a short distance, right? Some of the students on the ground may be in a circle, but all of them may be not. Some students may be standing in a straight line, but all of them may be not. So that is a short range order. To define these words, right, or to define the or to speak of the definition of a amorphous solids, you may also say that they are short range order. It is a general word. It does not point out to the one specific property. It's just a general word which defines the amorphous solids. Here also long range order means it is a general word which defines the crystalline solids. The word long range means any property you say, right, will be reflected as it is in all the corners, all the edges. Even if you cut the crystal from the two parts, right, both the parts will again show the same properties. That is what we mean by long range order, and same does not happen in the case of the amorphous solids. Sharp melting point and boiling point, right? As I said, if you take a crystalline solid and light it up, let's say within few seconds, let's say in 5 seconds, the solids get converted into the liquid. Let take the same type of the solid, or if you have two different crystals of NaCl, for another crystal also, if you test, for sure within 5 seconds it will get converted into the liquid. So sharp melting point and boiling point. So they melt up at a very fixed temperature. They boil up at a very definite fixed temperature. Same thing is not found in case of the amorphous solids. You may take a rubber, a eraser you have, right? If you try to burn it from the one corner, it may take 3 4 seconds. If you try to burn it from the another corner, it may take some different time. Some erasers are of a very good quality, so the time may be same. But when we talk about the rubber in a natural state obtained from the tree, right? In that case, we may for sure observe that one part of the natural rubber burns up quickly, another part takes time. So melting point, boiling point are not definite, not very sharp. Instead, they have some range, that natural rubber, it will melt between this temperature to this temperature, it will boil between this temperature to this temperature. So amorphous solids, they do not have definite melting point and boiling point.